This is going to be a video on how outside networks of circuits see sources of voltage and current. And this is pretty directly related to how you can ignore ideal independent sources for Thevenin resistance calculations. But for dependent sources, you need to include them. And this is going to explore why. It basically boils down to everything can be described by the IV relationship of the source. So let's start with ideal sources. Let's first start with this voltage source here. We know that it will always provide the same exact voltage, this red line here, for any load resistance that we give it. And if you think about voltage division, really we don't want to develop any voltage across this internal output resistance. We want to deliver it all to this V out. And we can prove that this resistance has to be zero if we find the slope of this line. In the previous two videos, I showed how the slope directly relates to the output resistance. So check those out for just an explanation of this. But we see that as this output resistance increases, the slope goes from vertical and slowly starts giving us some slope that's not zero or infinity, which means that we develop voltage across its internals as we change our load resistance, which is bad for ideal sources because we want to deliver the same voltage no matter what we connect to the outside. If we look at a current source, we see that we want to always develop if we look at a current source, we see that we always want to deliver the same output current no matter the load that we give it, which means intuitively we want this Thevenin resistance to be infinite. If you don't know how to relate these two together, they're one and the same through source transformation in my previous video. But basically think about current division. If we have some resistance here, we don't want anything to go through here. We want to have all of this current source be delivered out here. And if we look at an IV relationship, that means that no matter the voltage seen across this load here, we're always delivering the same exact current. And again, if we look at the slope, that means the resistance is infinite, which checks out for our intuition. And now if we look at dependent sources, there's four kinds. We have voltage-controlled voltage source, current-controlled voltage source, voltage-controlled current source, current-controlled current source. Here I'm just saying that we have some constant alpha, beta, gamma, delta relating all of these guys together. So let's say in the case of a current-controlled voltage source, and we'll take the simplistic example where the controlling current we're defining as the current through the source itself. And obviously that gives us some slope in our IV curve, which means that the resistance is not zero and it's not infinite, which means we would have to take the resistance of this into account from an outside perspective. Similarly, for a voltage-controlled current source, here, if we take the simplistic example of the controlling voltage as just the voltage across the source, then we have some slope here for the IV relationship that's not zero or infinite. And these guys basically are resistors. A resistor is saying, if you give me a current through me, I will produce a voltage. Here, if you give me a voltage across it, I will produce the same current. So if we ignore dependent sources of voltage-controlled current sources or current-controlled voltage sources, that's basically saying like we can ignore resistors, which we know is not true. So what about the case where we have voltage-controlled voltage sources and current-controlled current sources? Well, let's first look at this through an example. Let's say here we have a voltage-controlled voltage source where Vx is some constant times the voltage across this resistor. Well, we know that the current through this branch is alpha VA minus VA over the resistance. So by changing this value of voltage, we're actually changing the current through it as well. So even though the dependent value is not directly related to something through the source itself, well, even though it might not seem directly related, it is directly related. So we know that, in fact, these will both also have some sort of non-zero, non-infinite relationship that means they basically are just as important as resistors in the circuit for determining Thevenin resistance and whatnot. So in conclusion, from the point of view of external excitations, dependent sources have a Thevenin resistance other than 0 or infinity, which means we cannot just short them out or open them up in Thevenin calculations, which we'll see in the next video.